I am Kamal Bhatia, Assistant Professor, ABES Engineering College, Ghaziabad. This is a lecture series for the subject Network Analysis and Synthesis, and the title of Unit 1 is Fundamentals of Network Analysis. In Unit number 1, there are 5 topics: nodal analysis, mesh analysis, duality, source transformation approach, and the fifth one is matrix approach of solving circuits. So today we will discuss nodal analysis. That is the first topic of the unit number 1. So what is nodal analysis? In order to understand the topic nodal analysis, first of all discuss about what is node. So a node is a terminal or connection of more than two elements. This is uh, this is a node. If I talk about in this particular circuit, we can check that this is a circuit. So what is node? Node is a terminal or connection of more than two elements. So what are the elements? The elements can be resistance, inductance denoted by L, capacitance denoted by C, voltage source, current source. These are the elements. So if I talk about node, this particular point is node because this is a terminal or connection of more than two elements. This is also a node. This is also a node. And this one is node. So these are the four nodes in this particular circuit. So next talk about what is nodal analysis. In order to solve any circuit and to find the voltage or current in the particular circuit, a nodal analysis can be the best choice. So let us discuss what is nodal analysis. Nodal analysis can be applied for planar and the non-planar network. First of all, we should know the difference between network and the circuit. A closed loop circuit. Suppose this is a closed element and this can be a circuit, and in any network, any open part can also be there. So network is not necessarily a completely closed circuit, but a circuit should be the completely closed. So nodal analysis. Now, nodal analysis using the concept of KCL plus Ohm's law. We all know that what is KCL. KCL stands for Kirchhoff current law, and also we know that what is Ohm's law. The expression for the Ohm's law can be written as V is equals to IR. So in order to understand the nodal analysis, one should remember what is node. We discussed that these are the nodes in this particular example. So now check the procedure for nodal analysis. So this is the procedure for nodal analysis. First point is one of the node is taken as the reference node and its potential is 0 volt. That means ground. So in this particular circuit, in any circuit, while applying the nodal analysis, one should take the reference node that is 0 volt. The second point is identify and mark the known reference nodes. Third is assign the voltage at each non-reference node. If the voltage is not given, we can assign it as any variable, Vx, Vy, Vz, or something else. The fourth point is mark the current directions yourself. If it is not given in the questions, sometimes it is given in the question, the direction of current is given. But if it is not given, you have to take it yourself in any direction. So next is develop the KCL equations at the each known reference node. So these are the 5 points to solve any circuit and to find out the current or voltage in any circuit using nodal analysis. So let's take a question. This is the question number 1. Calculate the current across all the resistances using nodal analysis. So it's mentioned in the question that you have to solve this circuit and you have to find the current in all the resistances using nodal analysis. So let us remember that point. The first point is one of the node is taken as the reference node. So mark any node. Let's this node be the reference node, and this is ground, 0 volt. Again, this will be the ground. Similarly, this will be the ground, 0 volt. Assume one node as the reference node. So I assumed here this one, 0 volt, and this will be also the 0 volt, and the same here, this will be the 0 volt because no element is present in between these two nodes. So potential will be same. So the first point is mark the reference node. Now identify the known reference node. So known reference node will be, this will be the known reference node. The potential is not given. So let the potential is Vx. So we have covered 3 points till now. Reference node, non-reference node, and the voltage at each non-reference node. And the potential of this node will be the 10 volt. We can write it as this potential is 10 volt. This node potential is 10 volt with respect to ground. No need to take this node because we know that we can see easily in this circuit that the current will go or current will pass through the 2 ohm and 3 ohm because these are in the series, 2 ohm and 3 ohm in the series. So similar, and the single current will flow in 2 ohm and 3 ohm. So no need to take extra nodes. So that's why I mark the node Vx. This is the node Vx, and this node value is given 10 volt. So let's start. Mark the directions. Now the fourth point is mark the direction yourself if not given. So current direction is not given in this circuit. So I'm marking here the direction of current. Let's see, the current will flow like this in this particular. Let mark this current is going downwards, and let mark this current. So name it as I1, I2 current, and write down this I3. So at the node Vx, so I'm writing here at the node Vx, apply KCL. Now read the fifth point, develop the KCL equations at each known reference node. So known reference node is Vx. This is known reference node. So apply KCL at node Vx. This node was the known reference node, and reference node is 0 volt. So apply KCL at the node Vx. How many paths we will be able to see at the node Vx? There are 3 paths, I1, I2, and I3 current in all these 3 paths. So I1 is incoming, I2 and I3, I marked it as the outgoing current at the terminal Vx. So incoming current, we know the KCL concept is equals to sum of outgoing currents. So I1 is equals to I2 plus I3, very easy. Now check the point, develop KCL equations and use the Ohm's law. So what is Ohm's law? V is equal to IR. As per the mathematics, V is equal to IR is the Ohm's law. Here, I is given. I have written the expression for the current. So I am going to write here I is equals to V by R. Using the bracket here, let's. So what is the value of I1? Let's check. In which direction I1 is flowing? I1 is flowing from 10 volt to the Vx node. You can check here. I1 is flowing from the 10 volt node to the Vx node. So I is equal to V by R. Ohm's law. We are applying here Ohm's law. So 10 minus Vx divided by R means resistance 1 ohm. This resistance I have taken 1 ohm. So let's see again 10 minus Vx divided by 1 ohm. I'm using here Ohm's law. Ohm's law, I want to write it here. V is equal to IR is the Ohm's law as per the mathematics expression. And I is equals to V by R, we can write it. So this I is equal to V by R, I'm using here. I is equal to V by R, I am using here. So let's talk about the current I2. Now check from which node to which node I2 current is flowing. So I2 current is flowing from the node Vx to the ground as per the direction. Remember that the direction I have assumed here in this particular question because no direction was given in the question. You can assume anywhere. I assumed it as the downwards. You can take it as the vice versa also. So Vx, the value of current I2 will be Vx minus 0 divided by resistance will be 1 ohm. This is I is equal to V by R Ohm's law. So let's talk about the third current I3. This I3 current is flowing from the node Vx. Check, I'm describing Vx. This I3 current is flowing from the node Vx to the ground part. So what will be the final initial and the final node? Vx minus 0 volt divided by total resistance is 2 plus 3 ohm. So let's see what I'm writing here. Vx minus 0 divided by 2 plus 3. That means 5 ohm. So till now, we have written the expression for the current. Incoming current is equals to outgoing current. And we have also learned here that how to use the Ohm's law. I is equal to V by R in this particular question. So let's take a LCM here and we'll get the LCM 5. Here it will be the 5 Vx plus Vx divided by 1 ohm and 10 minus Vx. It will be the same. So on solving this, 6 Vx 10 minus Vx into 5 is equals to 6 Vx. On solving this circuit, we will get the value of 50 minus 5 Vx is equal to 6 Vx. So now it will be the 11 Vx is equals to 50 and the value of Vx will be 4.7 volt. On solving this, the value of Vx is 4.7. So initially, let's check the question. We need to find the current across all the resistances. So let's check. We got the Vx value. We got the Vx value till now. And now we want to find the current through all the resistance. That means 1 ohm, 1 ohm, 2 ohm, and the 3 ohm. So what is the value of I1? I1 will be the 10 minus Vx divided by, this was the I1. This was the I1 current. 10 minus, this was the Vx. 10 minus Vx divided by 1 ohm. So we got the value of Vx already. 10 minus 4.7. So I1 current will be the 5.3 ampere. Value of, now check the second current. We have assumed just now the value of current I2 in the downward direction. So let's write the value of V2 is Vx minus 0. This was the 0 ground potential. Vx minus 0 divided by 1 ohm. And the value of Vx, we know that 4.7. Answer of the current I2 is 4.7 ampere. Now I am writing here the value of current I3. This is ground. What will be the value of current I3? Let's write the value of current I3 is equals to Vx minus 0 divided by 5 ohm. What is the value of Vx? We got just 4.7. The value of Vx is 4.7 minus 0 divided by 5 ohm. So the value of current will be 0.9 ampere. So this was the final answer. I1, I2, and the I3. So I3 current was the current in the 2 ohm and the 3 ohm, both resistances. So this was the very simple question. In this question, we understand that how to apply the nodal analysis. This was the procedure, and using these 5-6 steps, we can easily solve any question. So let's talk about the second question. I'm taking another question. This question is asking the current across all the resistances using nodal analysis. So once again, you have to find out the current in all the resistances: 3 ohm, 3 ohm, 1 ohm, 1 ohm, 5 ohm. Right? So let's talk about the reference node. This was our first step. First of all, using nodal analysis, we have to mark a reference node. Reference means ground, 0 volt potential. So this was the reference. I have written here 0 volt all. And why all the potential nodes, bottom nodes are having the 0 volt? Because in between the two nodes, there is no any other resistance or voltage element. So the potential of these nodes are the same, 0 volt. So now the second step is, you can check the steps. First step was the reference node, and the second step, identify and mark the non-reference node, assign the voltage. So mark the non-reference node. What are the non-reference node? This is non-reference node. Vx, assume it as Vx. This node will be the same. This node will have the same value Vx because no element is present in between these two nodes. So one more non-reference node is this point, and one node is also, this is also the non-reference node. But when you practice this question, these type of question, you will see that there is no need to take this non-reference node and this non-reference node, this one, because there is no other branch here. So let's mark the value of, let's mark the direction of current. So this will be the direction of current. Assume it by yourself because it is not given. So I am assuming it as I1. I am assuming this direction downwards and naming it as I2 current. This current will flow from Vx to ground, and I am assuming it as I3. So I1, I2, I3. These are the three currents, and the 2 ampere current direction is given. So let's start with our procedure. Apply KCL at node Vx. Apply KCL at node Vx. So count the number of current element or path. I1 is incoming current, I2 is outgoing, 2 ampere current is incoming, and the I3 current is again outgoing. So incoming current, let's take I1 plus 2 ampere is the incoming current, and the I2 plus I3 current is the outgoing. This is very simple to understand. Whenever the current directions are not given, you have to assume it yourself. You can take it as downward also. I have taken this as the upward direction, no issue. So write down the value of I1 using the Ohm's law. I1 plus 2 ampere as it is. Then I will be going to write the I2. After that, the I3 current. So let's talk about the value of I1 current. So I1 current is moving from 0 volt terminal to the Vx terminal. I1 current is flowing from the 0 volt to the Vx terminal. So what will be the Ohm's law? Again, remember, Ohm's law is I is equal to V by R, V is equal to IR, or I is equal to V by R. So we have to write this expression, voltage by resistance. So voltage is 0 minus Vx. Current is flowing from 0 volt to the Vx node. Right? I1 current is flowing from 0 volt to the Vx node. So I have written 0 minus Vx divided by 6 ohm. Divide by 6 ohm. This is again important. This I1 current is flowing from the 3 ohm and the 3 ohm resistances. Both are in series because same current is flowing. So 3 ohm and 3 ohm will be in the series combination 6 ohm. So now talk about the current I2. Check the circuit. I2 current is flowing from the node Vx to the ground. Node Vx to the ground. So what will be the expression? I2 current Vx minus 0 divided by 1 ohm. Let's talk about the third current I3. Check the direction of I3. I3 current is flowing from Vx to the ground. Very simple. Vx minus 0 divided by 1 plus 5 ohm resistances are in series. So 1 plus 5 will be the 6 ohm. So I have written this one. On solving this equation, let's take the LCM minus Vx by 6. Here the LCM will be the 6 Vx plus Vx. This will be the 7 Vx divided by 6. Now take the LCM here also. 6 minus Vx plus 12 minus Vx plus 12 divided by 6 and 6 will get cancelled. 12 is equals to 8 Vx, and the value of Vx is 12 by 8 volt. That means Vx is equals to 3 by 2. This is 1.5 volt. So we got the value of node Vx here, but what we need to find, check the question. We have to find the current across all the resistances. That means I1 current, I2 current, and the I3 current we need to find. So we got the value of Vx, and we also written here what is the value of I1. Check this 0 minus Vx by 6. We got the Vx. Now we have to just put. Now we need to put the value of Vx is equals to, what was the value of Vx? Was 1.5 volt. We got here. Just so what was the expression of I1? I'm marking again. I1 current was flowing like this. This was the Vx. This was the Vx. What was the ground? This is ground. This is also a ground terminal. This is ground. That means reference node. These are very simple questions. Using nodal analysis to mark the I1. This was the I2. I'm repeating again. This was the I3. So that you can learn easily. I1 is equals to 0 minus Vx divided by 6 ohm. Because I1 current was flowing from ground potential to the Vx as per our direction. So what is the value of Vx? So I1 is 0 minus 1.5 divided by 6. We will get the value of I1 is equals to minus 0.25. On solving this, we will get the value minus 0.25 ampere. So what is the value of I2? This is one of the answer. Now what is the value of I2? I2 is flowing from Vx to 0. So Vx minus 0 volt divided by 1 ohm. I2 is equals to 1.5 volt. Just we need to put this value. I2 will have the unit current ampere. Unit of current is ampere. We all know that. Let's find the value of I3. I3 is flowing from Vx node to the, this is Vx node to the ground node. I3 value will be the Vx minus 0 volt divided by 1 plus 5 means 6. So I3 will be the 1.5 divided by 1.5 divided by 6. I3 will be the 0.25 ampere. So we got the answers. We need to find the current across all the resistances. So we got all the values. So we can solve any question. Just we need to take care of the steps. This procedure, once again, I am repeating, take the reference node, 0 volt, identify and mark the non-reference node, assign the voltage at each non-reference node, mark the current directions yourself if not given, and develop KCL equations at the each non-reference node and solve it. So one more condition is there in the nodal analysis, and that condition is known as the super node condition. So let us discuss what is super node condition. Super node condition occurs when an ideal voltage source, remember, when an ideal voltage source is present in between the two non-reference node. So let us check. What was the reference node? Reference node is the ground node. This is the reference node. This is the reference node, right? And this was a known reference node. Let's take the value Vx, and this value is Vy. No element is there. This value will be the Vy. So an ideal voltage source is present. An ideal voltage source. This 2 volt is the ideal voltage source is present in between the non-reference node. This was the non-reference node. Vx and the Vy. So it is difficult to solve this particular question or problem with the help of simple nodal analysis. So we have given the name super node condition. Now it's easy to solve this condition using super node technique. Apart from KCL and the Ohm's law, in the nodal analysis, we are going to use the KVL also in this particular question. So this was the super node condition. I hope you got the idea about the super node condition. This is very simple. If an ideal voltage source, this was the ideal voltage source of 2 volt. When an ideal voltage source is present in between the two non-reference node like Vx and the Vy. So it is difficult to solve this problem using simple nodal analysis, but we can solve this question with the help of super node condition. So let's solve this question. Calculate the current across all the resistances shown in this question using nodal analysis. So let's check and remember the steps. For nodal analysis, we need to mark, first of all, take a reference node that is ground. So this is ground. I am marking here ground 0 volt. So one reference node I have taken, and now mark the non-reference node. This is non-reference node Vx. This is non-reference node Vy. And this is again the Vy because no element is present in this node in between this node and this node. So it will act as the same potential node. So check the condition whether this question is the simple or the super node condition will be used. So we know the super node condition. Super node condition is when any ideal voltage source is present in between the two non-reference nodes. So I am marking here. This is the super node condition. Because of this problem, 2 volt is present. 2 volt is the ideal voltage source. Everyone knows that 2 volt, simple 2 volt is the ideal voltage source. So it is present in this question, it is present in between the non-reference node Vx and the Vy. So 2 volt, this is the super node condition. So how to solve the supernode condition? In supernode condition, we extra need to take the KVL. I mentioned here. Otherwise, it is similar to the simple nodal analysis concept. So we are taking this node as the single node. Let's talk about drawing again here. Plus minus 2 volt. This is Vy and this is Vx. So what is this? This is the supernode condition. We will try to apply here. Take it as the separate. Vx minus 2 volt minus Vy is equals to 0. On solving this, we can get Vx minus 2 is equals to Vy. This is our equation we got by applying KVL. We applied KVL here. Apply KVL above. This we are applying KVL from the Vx node across the Vx node, across the 2 volt and across the Vy. So we got the equation number 1. Let's call this equation number 1. And now solve this circuit as usual. What we discussed earlier in this particular lecture. So mark the direction of current. Current will, let's mark it as the I1. I1 current is flowing from 10 volt to the Vx. Let's mark the direction of current I2. I2 current is flowing from Vx to ground. Let's mark I3. This is, I'm marking it as outgoing direction. And once again, one more. This will be the I4. So there are 4 paths across which I have assumed the direction of I1, I2, I3 and I4. So let's talk. What was the I1? I1 was the incoming. Now we are going to apply the KCL. Apply KCL at supernode. Apply KCL at the supernode. So I am writing here I1 is incoming. You can check in this circuit. I1 is incoming. I2, I3 and the I4 is outgoing. KCL, we all know that incoming current is equals to sum of the outgoing currents. So let's write down the value of I1. Just we have learned in the last 2 examples also. So what is the value of I1? I1 current is flowing from 10 volt to the Vx. So 10 minus Vx divided by 60 ohm. All the resistances are in ohm. I2 current, check this. I2 current is flowing from Vx to the ground. From Vx to the ground. Vx minus 0 divided by 1 ohm. Now talk about the I3 current. I3 current is flowing from Vy to the ground terminal. So what we are going to write here, Vy minus 0 divided by 3 ohm. And I4 current is flowing from Vy node to the ground terminal. So Vy minus 20. This is, we have to take all the voltages across this path. Remember, again listen, I4 current. I4 current is flowing from Vy to the, I'm marking again, I4 current is flowing from Vy to the ground terminal. So 20 volt is also coming. So I'm taking it as Vy minus 20 as per the direction of current divided by 10 ohm. We all know that the KCL. we apply the formula Ohm's law, I is equal to V by R. So if we will solve this particular problem by taking the LCM, let's take 30 will be the LCM Vx, 30 Vx plus 10 Vy plus 3 Vy minus 60. Here is 10 minus Vx divided by 60 ohm. So on solving this, we can get the value of Vx is equals to, first of all, we will get the equation here. So we are getting here the equation 10 minus Vx is equals to 60 Vx plus 66 Vy minus 120. This is equation number second. On solving equation 1 and 2, on solving equation 1 and 2, we are going to get the value of Vx and Vy. We are going to get the value of Vx and the Vy. So Vx is 2.06 volt and Vy is 0.06. So we got the value of Vx and Vy. Now I want to find out the current I1. What was the current I1? Let's talk again. This was the current I1. This was the Vx. This is Vy. This is Vy. This is ground. This is ground. This is ground terminal. So I1 current value is 10 minus Vx divided by 60 ohm. You can get the result easily. 10 minus 2.06 divided by 60. 7.94 divided by 60. On solving, just you have to divide it. This is I1. Now, how can we get the value of I2? Where was the I2? This was the I2 current. This is I3 current. And this was the I4 current. Vx minus 0 divided by 1. So 2.06 volt directly. And again, I3 current is Vy minus 0 divided by 3 ohm. So Vy is 0.06 divided by 3 equals to 0.02 ampere. Correction, this is ampere. We got the value of I3 also. Similarly, we can find out the value of I4. What is I4? Vy minus 20 volt divided by 10 ohm. So what was the Vy? 0.06 minus 20 divided by 10 ohm. This is minus 19.4 divided by 10 is equals to minus 1.94 ampere. So we got all the value of current, using the super node condition. So we have to check in this, in each and every question, that whether it is super node condition is there or not. So this is the references. When Valkenberg network analysis, Sudhakar, Shyam Mohan, SP circuits and network. Disclaimer. Thank you for listening this lecture.